Hello again, welcome back to the lab. Today I'm going to show off these nice little Planar slash Finlux slash Loha Corp EL displays. These are all 512 by 256 pixels, and they're all the same size, and they all have the same interface, but what's interesting is there's like 3 or 4 different generations of it, all the way from 87 to about the 2000 era. And I'm going to hook these up and play Game Boy games on them. What I find interesting is these older displays, the Game Boy games play a lot better than on this newest one. I really like this newest one because it's very thin, and I have a project in mind for this little display here, so I'm kind of torn on using the new display, which is nice and thin, or the older one, which is a bit thicker. So I'm kind of up in the air on that. I'll turn them over and we can look at the guts. So here's a view of the guts. The oldest one is 87 and it has some dip chips on it. This one is 93, and these are the same exact circuit. This one has just got a little more surface mount on it. All these dip chips are gone. This one still has 2, but this one has 3 extras. And I mean, these chips are on this one, but they're on the bottom. And I'll take these boards off and we'll take a closer look. Then in 95, they came up with this one. This one's a little more integrated, and this is the DC to DC converter board that was an option, and I'll take that off. And then this is the latest one where everything is all integrated into a single board, which is kind of nice. It makes it a lot thinner. But unfortunately, this one has some bad things I don't like, and when I hook it up to the Game Boy, that'll be pretty obvious. So here they are with the top board off here. These 2 displays, this underside board is the same on both, so I'm not going to bother taking the other one off. But as you can see, there's a whole bunch of high voltage drivers. These are SuperTex drivers. There's 24 of them, and these do all the actual high voltage driving. And then here's all those surface mount chips on the bottom. What's interesting about this device here is there is actually a little PROM here. It's a 32 by 8-bit PROM, and this is acting as a very small state machine, and this runs a display. I was thinking about reverse engineering this just to see how it works because it looks really neat. And if I do use this older display, I could probably replicate all this top board functionality in a much smaller space. So I was thinking about maybe doing that because it is very superior to this newer style one. Then on this display over here, it's not a lot different from this one actually. It's got the same number of drivers. It has these more integrated drivers with more outputs on them, and so there's just not as many. And this one has a custom ASIC on it to do all the timing, and this one has a custom ASIC also, and these ones are all discrete logic. So that's a quick look at them. So let's fire them up and play some Game Boy games. Oh yeah, before we fire these up, I thought it'd be interesting to show where these come from. So when I went to the Hamfest a year ago in July, some guy was selling 2 of these, and he claimed they were for NASA camera control. I mean, I can't refute that or even figure out if that's true or not. But it does have like this inventory control thing, and it was made by AMX Corp. And I got 2 of these. I paid $5 each. And they have this display in there. It's the 512 by 256 with a nice touch screen. And what I thought was funny, these little buttons on the side. These are not actually connected electrically. They just touch the touch screen underneath the bezel here. This is the display that's inside it. I got 2 of these for $5 each, which I figured was a pretty good deal considering these displays sell for like $200, $300 on eBay. So I figured if I couldn't use it or whatever, I could probably resell them if I really wanted to, but most likely probably not going to. This oldest display, I got this at the Hamfest in like 1993 at the Hamvention. I paid $10 whopping for it, and this was brand spanking new on the factory styrofoam carrier too. So this display's practically never been used. Finally, I got this display out of this device. What this is a rack mount controller of some kind. It says Grass Valley Group, and that's like some kind of video editing stuff. And it says 15 bucks. I ended up paying, I think, $10 for this at the Hamfest. The guy wanted to get rid of it. And what's interesting is inside this there's like nothing. It's just that display. Inside it there's really not a whole lot. Just that display was sitting here. And then there's a circuit board with these encoders and buttons. And I like these encoders, so I will probably use those in something. And that's it. There was no electronics in it other than just the circuit board and that display. And then these new style displays, I picked these up on eBay. These were super duper cheap. I think I paid 30 bucks for these. And these are in pretty decent shape. There's a little burn in, but they do work. So they are definitely highly usable. So enough of that. Let's hook it up to the Game Boy and see what happens. So here's the setup. I got my FPGA video game board here. I soldered some wires to some of the vias on the routes to the video output. And that's going to this cable which is connected to the display. And then I got some power coming from the power supply. These take 5 and 12 volts. My little serial programming board, USB blaster, and so on. Now that was interesting. I saw it flash what was on the display like 5 hours ago when I was last using this. It was Battleship, and I saw it flash on there very briefly. So that means this display was actually holding that image in the glass there until it got reset. Oh, that was neat. So I got the Game Boy running. I'll upload a ROM to it. And there we go. Unfortunately, the lower 32 pixels are cut off because this is only 256 pixels high and the Game Boy is 144, and I'm doubling up the pixels here. So that means this display would have to be 288 pixels high to show the entire thing. This is just a test. I'm using this to drive these displays to test them and play around with them. I'm eventually going to make my own video driver for these. And like I said, this is just a test, so I just wanted to make sure everything was working, and it seems to work. So this is the old 1987 display, the oldest one I have. And it works awesomely. If I start it here. These lines here, let's see if I can zoom in on that. So this diagonal line here, on this display, those pixels look awesome when it scrolls. So if I scroll to the right here, that line is very solid. It doesn't flicker or anything. It looks perfect. Of course, this is kind of hard to play because I can't see the ground. And there's like holes in the ground, but as you can see, it works quite well other than not being able to see the bottom couple pixels. So now I'll put the newer display on there. So I'm going to put this display on. This is the newer one. This is the next generation model. So it just plugs in. Connector goes to the bottom. And turn the power supply on. And there it is. And that display is really loud. You can probably hear that whistling whine. That's actually the display itself. This display looks really nice. It's very kind of orangey. The other one was more yellow than this. So now if I reset the game, start again. Now watch this diagonal line. It'll kind of blur a little. It looks kind of like it blurs a little. That last display, it was very, very solid. This one, it kind of blurs. Especially when it scrolls fast. Kind of like, it's like it only refreshes every other frame or something. There's a hole there somewhere. So that's that display. Now I'll put the newest one on there, which I don't like as much. So I got this one hooked up. Now I will load the ROM. There we go. This one, you can see a little burn-in on the display right here. There's like a soft key there, and there's one there, and you can kind of see them. There's a few others, but they really don't show up, just mainly these two. So now if I start this, now watch this diagonal line. It'll appear to be twice as wide as it actually is. Everything gets like really wide, and then on the edge where there's a black edge, you can kind of see a comb effect. and that's because this display uses interlacing, and I think the reason they do this is to save power. Those last displays, they draw about an amp at 12 volts, and this one only draws about 500 mils. So that kind of is my theory, and it just looks fairly crappy when scrolling compared to those other ones. I mean, the game still plays okay, but it definitely doesn't look as good. Yep, and there's one of those invisible holes because you can't see it. So yeah, that means all these displays, they do work. They all have the exact same power requirements. And the timing is the same on all of them. So that's kind of nice. It's pretty cool to be able to just plug any one of these displays and then they all just work. But unfortunately this one, I like this one the best because it's the thinnest and smallest and most integrated, but unfortunately it has that interlace. And as far as I know, there's really no way to turn it off. It's kind of interesting, this display also has a low power mode, and the datasheet says that brightness and contrast are slightly reduced in low power mode, but it's a bit more than just slightly. Old Mr. Datasheet here says pin 5 is the low power mode. The power consumption of the display is lowered to the low power values if the pin is low, internally pulled high if left disconnected. So right now it's not connected, so it's pulled high, so we're going to pull it low and see what happens. So pin 5 is right here on that connector, so I got this ground clip just plugged in there, and I'm going to insulate that with a piece of paper. And now I got my clip I can just connect to ground to try out that low power mode. So here it is in normal mode. Now I'll ground this out, and there's the low power mode, and you can really see that burn in. It says post proc E there. You can see colorize there. I can see UD invert zoom. There's this line here, so obviously there was a line across the display. Turn the light off, and you can really see in the corner here where it says 2D secondary controls, frequency fusion 3, focus, post proc, colorize, sweep 50, and then these are obviously some horizontal lines. What I find interesting is the burn-in actually lights up brighter instead of the opposite way. You'd think with burn-in it would tend to be darker, but for whatever reason it actually tends to be brighter. I wonder why that is. Let's see, I'll blank that display like that, and then now you can actually see all that burn-in. And if your camera doesn't like to focus, you just put something near it in its line of vision that has some edges it can pick up. Like that. So now we can see it says focus, post-proc, frequency fusion, 3, 2D, M mode, color, PW, CW, ANGIO, ANGIO, secondary controls, a whole bunch of other little things. So I don't know what this was from, maybe some kind of medical equipment. But again, like I said, it's interesting that the stuff that's burned in actually shows up brighter. Now if I take that low power pin high again, then it gets a lot darker, and you almost can't hardly see the burn-in unless you're actually running a game. So this is that 3D effects demo thing that never was released. It was just a programming demo. I think it looks pretty cool. Again, the bottom's cut off, but it really doesn't matter for this demo. The important stuff is all visible. So what I did to get the Game Boy on here, I use a dither pattern. So every Game Boy pixel can be one of 4 colors. So what I've done is each pixel of the Game Boy is actually 4 pixels on this display. If I zoom in, you can probably see that. So what I've done is for the white parts that are the brightest, it's just all 4 pixels are on. For the dark parts, all 4 are off. And then for one of the gray levels, 1 pixel out of 4 is on. And then for the other gray, you can see that up. You can see that right there, the 1 of 4. And then for this, it's every other pixel in a in a checkerboard pattern. And that's basically how it works. I can do it without the dither pattern, but I can't do a grayscale on this display, so obviously it doesn't look very good. So this looks a lot better with just the problem of the bottom gets cut off a little bit. So a lot of the games are playable, but again, this is just a test. I'm just making sure these displays work and I can interface to them. So on this game, it's kind of interesting. It does a 50% flicker, and that causes weird things to kind of happen. They look like really dark, so some of these look really dark, and that's because they're doing a 50% flicker on them. So now we'll compare this to the old style display to see how that one looks compared to this one. So you can see that it was really dark there because it was doing that 50% flicker. So now I'll put my oldest display back on here and we'll compare to see what that looks like. Oh yeah, before that, I'm just curious. I'm going to put this back into low power mode since this game seems to have a lot of black in it. So yeah, it looks really, really horrible compared. There's full brightness, half brightness. Man, that half brightness mode, the burn-in really shows up. Interesting. So here's my oldest display. I'll reset it here just to get a good baseline. There we go. And that logo scrolls really smooth on this. So now that 50% flicker, it was not that dim as on that other display. And you can't even hardly tell that those sprites are flickering at 50% either. They just look a bit dimmer, which is how they should look on the LCD of a real Game Boy. So for the end of this video, I will patch in the audio from my Game Boy here and then run a really neat little Game Boy demo so you can see and hear what it sounds like. And as always, thanks for watching. Be sure to comment and subscribe. It really helps.